ERO.
Yeah.
To fully understand about the ERO, how about we watch the video first?
Let's go.
Hello everyone, today I'd like to delve into the topic that forms a fundamental aspect of a matrix mathematics, which is ERO. So, what is ERO? Which is also known as the elementary row operation. Basically, EROs are fundamental techniques used in linear algebra and matrix operations. These operations allow us to manipulate matrices systematically and preserving their underlying mathematical properties. Therefore, let's look at the notations that we should be more focused while applying ERO in mathematical operation. Firstly, interchanging rows. This operation involves swapping the position of two rows within a matrix. The notation shown on the first sentence indicates that the matrix B has its I row interchanged with its J row. Interchanging rows can sometimes simplify a matrix or make certain operations more straightforward. Secondly, we should take note the scalar multiplication of a row. Here, a specific row of a matrix is multiplied by a scalar. The notation KIB indicates the I row of a matrix is multiplied by the scalar K. This operation can help in scaling a row and make some elements more prominent or adjusting the matrix for further operations. Lastly, addition of a scaled row. This operation involves adding a scaled version of one row to another row. The primary goal of this operation is to modify the elements of a matrix, typically aiming for zeroing out the specific entries. Hence, let's go through some quick examples for these concepts that we have covered so far.
So for the first example, given that A is 1, 2, 2, 3. So question A, which is B1 double arrow with B2. So we write out the matrix first. 1, 2, 2, 3. And write the operations beside the matrix. B1 double arrow with B2. Which means that we interchange the first row of the matrix with the second row of the matrix. Which is now 2, 3, 1, 2. So for question B, negative 5B2. Also, we write the operations beside the matrix. Negative 5B2 means that we multiply the second row of the matrix with negative 5. So the first row of the matrix will remain the same, but the second row will times with negative 5. 2 times negative 5 is negative 10, and 3 times negative 5 is negative 15. Last C, which is B1 plus with negative 3B2. Same, we write the operations beside the matrix. So, which means that we use the first row of the matrix plus with B2 that times in negative 3. So the second row of the matrix will remain the same, 2, 3. But the first row we need to plus with B2 times negative 3. So 1 plus negative 3 times negative 2, which is 1 minus 6. We get negative 5. And the second one, 2 plus negative 3 times 3, which is 2 minus 9. We got negative 7. That's it. So now we proceed to the next example, which is example 2. We write down the matrix first. So the first operation is B1 double arrow with B2, which means that we interchange the first row of the matrix with the second row of the matrix. So 2, 5, 3 will become 1, 2, 1, and 2, 5, 3 will move below. The next operation is negative 2 BI, which means that the B2 we plus with the B1 that has been multiplied by negative 2. So which will become 2 plus with negative 2 times 1, which is 2 minus 2, which is 0. 0. So 5 plus negative 2 times 2 is 5, and 5 minus 4, which is 1. And 3 plus with negative 2 times 1 is 3 minus 1 equal to 1. And the next operation is B3 plus with 3B1. So in this condition, I write here, only the third row will be changed. So we write down the first two rows first. The third row of the matrix will plus with B1 that has been multiplied by 3. So negative 3 plus 3 times 1, negative 3 plus 3 is 0. And 1 plus 3 times 2, which is 3 times 2 is 7. And 2 plus 3 times 1 is 5. And we proceed. B3 plus negative 7, B2. So only B3 will change, so we write down the first two rows first. times 2. So B3. 0 plus negative 7 times 0, which is say 0. And 7 plus negative 7 times 1, which is 7 minus 7, 0. And 5 plus negative 7 times 1, which is negative 2. So the last step is negative 1 over 2 b times 3. So we write down the first two row, and the last row is 0 still, and the negative 2 times is negative 1 over 2 b3. So negative 2 times negative 1 over 2 equals to 1. So that's it.
So now we move on to the second part, which is row echelon matrix REM and row reduced echelon matrix RREM. So row echelon matrix REM has the following properties. We look at the second point and the third point first. So for each row that does not contain entirely zeros, the first non-zero entry is 1, which means that leading one. We call it as leading one. Next, for two successive non-zero rows, the leading one in the higher row is further left than the leading one in the lower row, which means that the number 1 in the upper row will always be at further left than the second row. Then we back to the first point. Any row consisting entirely of zeros occurs at the bottom of the matrix, which means if we have a group of zeros, we always put at the bottom of the matrix. So on the other side, REM, which has the same property as the REM before, but with just with one additional property, which is for reduced row echelon matrix REM, the leading one of every row contains 0 and above is in that column, which means that in the column of the matrix, besides the leading one, anything else is 0. Please be note that if a matrix is REM, the matrix is REM, but if the matrix is not REM, the matrix is not REM. So this is the final example question for me, which is example 3. So given matrix A, we need to convert it to REM and RREM. So for REM part, we just need to remember the properties, which is, for example, the leading one of the upper row is always be the further left to the row below. So which means that if you look at this matrix, the first row is okay already because you already have leading one. So the second row, we need to change second row and third row of the first column. We need to change it to 0. So we need to perform this operation to get 0 in the first column. Next, we need to let the second row, second column, which is this element negative 7, to become 1. So that it can be the leading one of the second row. So we need to times with negative 1 over 7 to get the 1 in the second row, second column. And the third row also, we need to, this negative 5, we need to multiply with negative 1 over 5 to get 1. So we proceed. So we already have the leading one in second row. So we need to have the leading one for the third row also. But we need to change this 1 to 0 first. So we need to perform the operation R3 equals to R3 minus R2, which is 1, this 1 minus 1. We will get 0. So the 10, this 10 over 7, we need to change it become to 1 so that it can become the leading one. So we need to times the 10 over 7 with 7 over 10. So we will get 1. So we get our REM. So next, RREM. We just get the result from REM and we put it here. So for REM, we just need to remember the additional property, which is the column of the leading one will have 0 in anywhere else. So we need to change this one and this one to become 0. So first, we need to perform this operation, which is 2 minus 2 times 1, which is to get 0 here. So after we perform the operation, we get 0 in this column, the first of this column. And next, we need to let this 13 over 7 to become 0 also. Sorry. So we need to let this 13 over 7 to become 0 also. So we use R1 minus with negative 13 over 7 times with R3. So we will get the 0. So finish for the first row. And next, we go to the second row, which is this 4 over 7. We need to let it become 0 also to comply with the properties. So we need to use R2 minus with negative 4 over 7 R3, and we'll get 0. So this is our REM, which follow the properties, which is the leading one. Anywhere else of the leading one will get 0. So the C question asks about the rank of the matrix. So the rank of the matrix, we need to refer to either of the REM or the REM. So if you look at the example, which is in REM, we get 3 non-zero rows. So the rank of the matrix is 3. That's all from me. Thank you.
Do you understand right now what the ERO?
Yeah, I'm fully clear with this ERO topic. But what the application of this ERO?
Let me tell you. Application of elementary row operation, or ERO. First of all, the application of the ERO is linear transformation. Elementary row operations are fundamental in linear algebra and can be applied to understand and manipulate linear transformation. For example, they are in use in computer graphic for image transformation. Secondly, statistics. Matrices are in use in multivariate statistics, and the ERO can be applied to simplify matrices for easier statistical analysis. Last but not least, coding theory. In error detection and correction code, matrices are in use to represent encoding and decoding process. Elementary row operation help in manipulating these matrices to improve error correction capability.
Is that all the application of ERO?
No, actually, there's a lot of application of the ERO in our life. And I'm curious one thing about you. Why you ask me about the ERO?
Actually, our next lecture, we will learn about ERO.
Oh, I see. Morning, guys.
In conclusion, just as we rearrange our daily tasks or resolve issues in real life, EROs in math help us simplify and solve problems in matrices. This shows how making smart adjustments both in math and life can lead to better results. Thank you for staying with us.